Hello students, welcome back into my channel. In this video, I'm going to discuss how we solving exercise 1A regarding reciprocal trigonometric functions of this book, Mathematics, Analysis and Approaches High Level 2. Right, let's start with number 1. Okay, number 1, 1A, cosecant pi third equals 1 over sine. Why? Because cosecant is inverse of sine. Yeah. Or sine is inverse of cosecant. So cosecant pi third equals 1 over sine pi third. 1 over sine pi third as well, you can writing like this. Sine power -1 pi third. Okay. Okay, this expression same with 1 over sine pi third. Okay, or same with arc sine pi third. Yeah, arc sine pi third, it means inverse of sine. Okay, right. Let's find the solution of 1A. So sine pi third equals √3 over 2 or √3 half. Or we can simplify, becomes 1 times 2 over √3 equals 2 over √3. Or you may simplify times √3 over √3. It is 2/3 √3. Okay, let's continue. B. Cotangent 2 pi third. Cotangent is inverse of tangent. So cotangent 2 pi third equals 1 over tangent 2 pi third. 1 over, I'm going to find tangent 2 pi third minus √3. This is the solution. Or if you want to simplify, you may calculate with √3 over √3. It is minus 1/3 √3. C. Second, 5 pi over 6. Okay. Second equals 1 over cos 1 over cosine 5 pi over 6, because inverse of second is cosine, or inverse of cosine is second. So it's going to be 1 over cosine 5 pi over 6 by calculator minus √3 half. Or if you would like to simplify, it is 1 times minus 2 over √3. It is minus 2 over √3. Or if you would like to continue to simplify, it is minus 2 over √3 times √3 over √3 becomes minus 2/3 √3. Next. D, cotangent pi. Cotangent pi. Cotangent, inverse of tangent, equals 1 over 0. 1 over 0 is undefined. Yeah. Okay. That's the symbol. Because 1 over 0, there is no number. So without using calculator, find cosecant x, secant x, and cotangent x given. Sin x equals 3/5 on this interval, 0 to half, to pi half. Okay, but firstly, I will, for 2a, I will sketch the quadrant. Okay, quadrant 1, 2, 3, and 4. Okay, quadrant 1, 0, 2, pi half. So the interval of these questions only here. Okay, as long as this interval. And so because sign positive here. Now sin x equals 3/5 cosecant inverse of sin x, okay, equals 5/3 through a triangle, right angle triangle. If we sketch like this, 5 here, okay. And then if this is x, sine, it means 3 here and 4 here. So cosecant is 5 over 3. Now, to find cotangent, it means we have to find cosine first. Cosine x, 4 over 5. So it means tangent. So tangent x equals 3 over 4, or sine over cosine. Okay. But I would like to using 3 over 4. Okay. So how about cotangent? Cotangent is inverse of tangent, or opposite of this fraction, 4/3. Okay. Cosecant already this one. Second, second not yet. Okay, second, 1 over cosine x. Cosine x, 4/5. Second, it means opposite of this fraction. So 1 over 4/5, it is 5/4. Okay. So cosecant, already this one. Second, and cotangent. Next, B. Cosine x to third, and the interval 3 pi half to 2 pi. It means on quadrant 4 here. Okay, so cosine x happening on this interval. If we sketch the triangle, Okay. Cosine, it means if this is x, okay, 2 here and 3 here. Okay. Now we're going to find this side. 3 squared minus 2 squared. 9 minus 4, 5. So it is root of 5. Okay. So cosine x, 2/3. And then, yeah, on yeah, on quadrant 4, the value of sine is negative. Okay. The value of sine is negative. So sine x equals negative root 5/3. Okay. About tangent. Tangent as well, negative, because sine negative. So tangent is negative. It's one, this side over this side, in front of closed. Yeah, in front of x over closed of x. So cos 5/2. Okay. Next, cosecant x. Cosecant x is 1 over cosine x. Okay, so 1 over cosine x is 1, 2/3 equals 3/2. Now second x equals 1 over sine x. Sine x is 1, it's 1, negative root 5/3. So it becomes 1 over minus root 5/3. It is minus 3 over root 5. Cotangent. Cotangent x is inverse of tangent. So opposite of this value comes negative 2 over root 5. Or you may simplify being negative 2/5 root 5. As well as one you may simplify becomes negative 3/5 root 5. Number 3. Find the other 5 trigonometric ratios if cosine x equals 3/4 and the interval from 3/2 pi to 2 pi. Okay. Firstly, I will sketch the quadrant and the cosine x values are on this quadrant 4, because this quadrant is the quadrant of 3 pi half to 2 pi, this quadrant. And next, after that, okay, I will sketch the triangle. Cosine x, 3/4. If x here, means 4 here and 3 here. How about this side? This side is 4 root of 4 squared minus 3 squared. It is root of 7. Okay, root 7. On this quadrant, cosine cosine is positive. Okay. Sine is negative. Okay. Tangent is negative. And then cotangent as well negative. Okay. Second, yeah. Second is inverse of cos. It means positive. And then cosecant is negative because inverse of sine. Right. So if cosine x 3/4, okay, it means sine x minus because on quadrant 4, sine x root 7 over 4. And tangent x equals, tangent is negative because on quadrant 4, root 7 third. Okay. After tangent, cotangent. Cotangent x, opposite of tangent, and cotangent is negative. 3 over root 7. Second x. Second is opposite of cosine. This one. So positive 4 third. After that, cosecant. Cosecant x equals negative because on quadrant 4, second is opposite of sine. It becomes 4 over root 7. Okay. Next, B. Oh, apparently I need more space. Okay, B. Sine x equals negative 2/3. Okay. I'm gonna clean first this area. Okay. Right. Okay. Sine x on this interval on quadrant pi to 3 pi half, this quadrant. The third quadrant here. This quadrant, sine negative, then cosine negative as well. Okay. Tangent positive. Okay. Cotangent positive. Okay. Second negative. Cosecant negative. Okay. So if 2/3, it means 2 here, this side, and 3 here. We are going to find this side, the base. Base of this triangle is 3 squared minus 2 squared. Okay. It is root 9 minus 2 minus 4 is 5. Okay. Square 5. So square 5 here. Sine already, sine x already. minus 2/3 cosine x equals minus as well, root 5/3. Okay. Tangent, yeah, tangent is, yeah, tangent positive 2 over root 5. Or you may simplify, becomes 2/5 root 5. Cotangent. Cotangent x, opposite of tangent, and cotangent positive root 5 half. Okay, second is negative. Okay, second is opposite of cosecant. Okay. So second is, yeah, second opposite of, yeah, cosine, opposite of this. Okay, so negative 3 5. Cosecant is opposite, is the inverse, sorry, inverse of sine x. Inverse, it means opposite of negative 2/3. So, and cosecant sine is negative. Okay, opposite of this fraction, 3 half. Okay, that's number 2b. Okay, cotangent already. Okay, okay, tangent to 5. Okay, all right. Last one. C. The interval on 0 to pi half. Here the interval. Yeah, the quadrant here. Okay. And the triangle. This is secant x equals 5 half. Okay. X here. If a second, it means if secant x equals 5 half. Yeah. Second is inverse. Yeah. Inverse of cosine. 1 over cosine is secant. So it means cosine x, okay, cosine x equals 2/5 opposite of 5 half. So if cosine x 2/5, it means 2 on base, 5 as the gradient. Okay, right. This side is square root 5 squared minus 2 squared equals square root 21. Okay. On this quadrant, all sign positive. Okay. Secant, cosecant, tangent, and so on is positive. So sine x root 21 over 5. Okay. And then cosecant 5 over root 21. You may simplify. It becomes 5 over 21 root 21. Tangent tangent x root 21 over 2. Okay, in front over close. And cotangent is inverse of tangent or opposite of this fraction 2 over root 21 or 2 over 21 root 21 d. D cosecant x. It was 2. And the interval pi half to pi. Okay. Pi half to pi, it means here. The second quadrant. On the second quadrant, sine, okay, sine is positive. Okay. Cosine negative. Tangent negative. Okay. Cotangent negative. Okay. Second is negative, while cosecant is positive. Okay. Meanwhile, the triangle, okay, cosecant inverse is sine. So sine x 1 over 2. If x here, sine x, it means 1 here and 2 here as the slope. Now, how about this side? This side is square root. We are going to find 2 squared minus 1 squared. Yeah, square root 3 here. Cosine x already, 2 sine x already, half. Uh, both both are negative, are positive. Now cosine x negative. Okay. Root 3 over 2. Second minus as well. Okay. Second opposite of cosine or minus 2/3 root 3. Okay. After that, tangent x negative. Okay. Tangent 1 over root 3. Or you may simplify like this one. Cotangent minus opposite of tangent root 3. Okay. What else? E. Tangent beta equals half. And beta interval pi to 3 pi half. Okay. Okay, the interval on this quadrant 3. Okay. And tangent beta equals half. Means the triangle, if beta here, 1 here and 2 here, about the slope. 1 squared plus 2 squared, the root 5. And on this quadrant, sine is minus, cosine as well minus, okay, cosecant, of course, minus, secant minus, tangent positive, cotangent positive. Okay, so sine beta equals 1 over root 5. Okay, and sine is negative. Okay. Cosine beta, cosine is negative. Cosine 2 over root 5. How about cosecant? Cosecant beta, cosecant is minus, opposite of sine, root 5, secant is negative, opposite of cosecant, and cotangent is positive, this one, and opposite of tangent, 2. Okay. Okay. F. Oh, number 4, I'm going to clean this area first because I need this area for this one. Yeah. Okay, better this area. Okay, wait, I need more duration to clean this area because I want to explain part F. Okay. All right. Part F, cotangent theta, 4/3. Okay. And the interval pi to 3/2 pi. Okay. The interval here, pi to 3/2 pi here at the third quadrant. And the triangle. So tangent is inverse of tangent. And tangent theta inverse of cotangent, it means the value is opposite of this value, 3/4. If theta here, it means 3 on this side and 4 on this side. How about this row? Square root of 3 squared plus 4 squared. It is 9 plus 16. Root 25 is 5. 5 here. Now, on this quadrant, sign is minus, cosine minus as well, cosecant minus, secant minus, tangent positive, and cotangent positive. Now we're going to find the values. Cotangent already, tangent already. Now we start from sine. Sine theta, 3 over 5. 3/5, and sine is negative. Cosine theta, negative 4/5, 4 over 5. Then cosecant theta, cosecant is negative, and the values is opposite of sine. 5/3. Secant theta, secant is negative, and the values opposite of cosine. 5/4. Number 4, using the graph of y equals cosine x, sketch the graph of y equals 1 over cosine x equals secant x for interval x from negative 2 pi until 2 pi. Check your answer using technology. Right. Firstly, I will find the values of cosine 0. Cosine 0 equals 1. Same with secant 0 equals 1. This cosine 0 equals 1, so secant 0 as well, 1 here. Okay. Next, secant 60 equals 2. And then secant 120 equals negative 2. Okay. So if negative 2, 2 here, okay, but 60 around, around here, okay. Yeah. And then secant 120, we are going to sketch secant first. Okay, 120, this is pi, half pi, I mean. Okay, and then this is pi, 3 half pi, around here, 2 pi, minus half pi, minus pi here, - 3 half pi, and minus 2 pi. Okay. The interval from negative 2 pi to 2 pi. Right. So secant 120, okay, equals negative 2. Yeah, it means if negative one if 120 secant 120 equals negative 2, it means if this is 90, it means 120 around here, and negative 2 is 1, so it becomes here. Okay, let's say we are going to sketch now, and then cosine cosine minus 2 pi equals 1 minus 2 pi. It's 1. Cosine is 1. Secant minus 2 pi equals 1 as well. So they have same coordinates point here. Then secant minus 60, this equals 2, and secant minus 120 equals minus 2. And then cosine 2 pi equals 1 here. Secant 2 pi as well equals 1. Then secant 300 equals 2. Okay, secant 240 equals negative 2. And then secant minus 300 equals equals 2. Okay, sorry. So secant minus 240 equals minus 2. So cosine already, so now we will focus on secant. Okay. Firstly, this if we sketch a secant graph, yeah, this one first this one 60 and 2, so it's 1 around here, and as well secant negative this one secant negative 60, 2 as well around here. Okay. So it means the graph would be like this. Okay. Look at the maximum point of cosine x being the minimum point for secant x. Okay. And as well here. So if secant 300 equals to 300 around here. Okay. And so it will be like this. Okay. And as well, secant, yeah, already. So now this, so it means this is like this because maximum being negative for secant. Okay. After that, secant 120 being negative 2. So if 120, this is 90, so 120 around here. Okay. So this, and secant 90 equals -1. Second pi, second 180 second pi equals -1. Here, and as well second second, it's now second, not second one, not second 120, but second positive, yeah, yeah, second positive 120, second negative 120, around here. So the maximum of cosine x being minimum of secant x. The minimum of cosine x being the maximum of cosine x. Yeah. So it will be like this, the graph. We sketch. Like this, right? So if we look this, that there is asymptote actually like this. Yeah, I have sketched this both graph. This the color graph is a graph of y equals cosine x, while the blue graph is the graph for y equals 1 over cosine x or secant x. Okay. So how about the asymptote? The asymptote happening asymptote happening okay, on on x equals on y on x-axis -3 half pi. Okay, -3 half pi. Yeah, around this is -1 pi. This is -2 pi. Yeah, asymptote here. So we can sketch the asymptote. Okay, and after that, the asymptote happening on -1/2 pi. Why asymptote happening on this theta on this pi? Because if you calculate cosine, if you calculate secant -3/2 pi, it will be have undefined. Okay, so x equals -3/2 pi being the asymptote as well, -half pi, -half pi. Here, the intersection point, the intercept point. And next, half pi. This the asymptote here. Okay. And as well here. 3/2 pi. And just now, we found that the maximum point of cosine x is the minimum point of secant x. Yeah. This is the pointer, so I have to give point. Okay. Right. So this is the graph. Next. Number 5. Using the graph of y equals tangent x, sketch the graph of y equals 1 over tangent x or cotangent x for x interval negative 2 pi to 2 pi. Okay. I have sketched this graph for y equals tangent x. For tangent x, look that if we if we calculate on calculator that if tangent x equals 1 as well, cotangent x equals 1. So if tangent x equals 1 here, okay, uh, cotangent x, if tangent x equals 1, here, no, not this one. I'm going to using different color if tangent x. If tangent x equals 1, cotangent x as well equals 1. And it's happening on here. Four coordinate point. Okay. Happening on it. Happening on the coordinate point happening on -7 4 pi, this coordinate point, comma 1, as well, this coordinate point, -3/4 pi, comma 1, and then this coordinate point, 1/4 pi, comma 1, or 45, and this one, 225, 225, 3/4 pi, comma 1. Yeah. And I have calculated as well, calculator that this is the first point, the second point, second note, I mean, when tangent x equals -1, okay, as well cotangent x equals -1. Okay, and it's happening on coordinate points. We have to identify first the -1. -1, oh yeah, here. Okay. 1, 2, 3, 4. Yeah. Okay. 4. So it's happening on firstly this one, minus 225. It means minus 5/4 pi, comma negative 1. Secondly, this one, minus 45. It means minus 1/4 pi, comma negative 1. Thirdly, this one, minus 135, or 3/4. Okay, not minus, but positive already here at the right side of x axis, minus 1. And this coordinate point, 315, or 7/4 pi, comma negative 1. So cotangent x graph, okay, will passing through this this coordinate point 1, 2, 3, 4, 5, 6, 7, 8. Now we are going to find the intercept point of cotangent x and x-axis. Okay. I have calculated through calculator the intercept point, tangent x. Yeah, tangent x equals 0. Okay. When x, no need to find that, but I have calculate when x equals minus 2 pi. Okay, minus 2 pi, this one, pi, 0, positive pi, and negative, and positive 2 pi. Minus pi, 0, pi, and positive 2 pi. Tangent x. So cotangent x. Now cotangent x. Cotangent x equals 0 happening when x, okay, when x equals minus half pi, and then minus 3 half pi. This is 90, minus 90. This is minus 270. 90, or pi, okay. Half pi, I mean half pi. Sorry. And 3 half pi. Okay. So we can find minus 3 half pi around here. I'm going to use another color, the different color, this one. Okay. The intercept point between cotangent x and x-axis as well. Half pi is pi, so pi here, minus 2 pi, positive pi, and 2 pi here. So the intercept point around here, okay. After that, positive half pi around here, and 3 half pi around here, okay. So if we sketch the graph, it will be, I'm going to using another color. Better is this color. Okay. It will be like this. through dash 3 coordinate point. Okay. Okay. Like that. And then it will be like this. Through this 3 coordinate point. Okay. And like this. Okay. Now, regarding the the graph. Now, regarding the asymptote. Okay. So this is the graph of tangent x and cotangent x. Yeah. Look, this is they have the same coordinate point here. Okay. Y equals 1. Because now I have calculate this one, this, okay, which one? This 1, 2, 3, 4. Okay. Those are here. 1, 2, 3, 4. And the next is y equals negative 1. 1, 2, 3, 4. This. Okay. 1, 2, 3, 4. Okay. And the answer point, okay, 1, 2, 3, 4. These are the answer point between cotangent x and x-axis 1, okay, 2, 3, 4. Right. After that asymptotes. For asymptotes, the asymptotes happening when x uh, when x equals, yeah, minus 2 pi, okay, minus 3 half pi, minus pi, minus half pi, okay, 0, half pi, pi, 3 half pi, and 2 pi. Okay. We are going to find this one, minus 2 pi. Minus 2 pi over here. So we create a straight line. Okay. As the asymptote. Secondly, minus 3 half pi. So this is 2 pi, minus 2 pi. Okay. And this is minus pi. Okay. This one minus 3 half pi. So the asymptote are here. Okay. On your book, you may sketch the straight line. After that, minus pi here. Don't forget to sketch your graph on millimeter block book. Okay, and then after that, minus half pi, around here. Okay. Wait. This is minus half pi. Okay. 0, of course, here. Okay. Then half pi, positive half pi here. Pi here. After that, pi. Then 3 half pi. If this is positive 2 pi, this is 3 half pi. It's gonna be yeah, that. Okay, let's move to number 6. Use technology to sketch y equals secant x and y equals cosecant x plus pi half on the same set x-axis for x interval negative 2 pi to 2 pi. Explain your answer right. This I have explained. I have sketched on a graph, and this is the graph of y equals secant x and y equals cosecant x plus pi half. If you sketch this graph, okay, that y equals cosecant x and y equals cosecant x plus pi half happening on one graph. So they have same coordinate point. Okay, so therefore, if this graph for cosecant x plus pi half as well, you have to sketch graph of secant x at the uh, same graph. Okay, so why? Because they have same coordinate point. Okay. Okay. They have same coordinate point. So for our note that uh, when secant x equals 1 as well, cosecant x equals 1. Okay. Cosecant x plus, sorry, cosecant x plus pi half. Okay. Equals 1. And it's happening on yeah, x equals minus 2 pi, 1, okay, after that 0, okay, and then 2 pi. And secondly, when secant x equals negative 1, cosecant x plus pi half as well equals -1 and happening on x equals this, okay, pi, -pi, and x equals here, equals pi. The next note is, yeah, the asymptote happening on -3 half pi. Okay, 3 half pi. If this is minus pi here, okay, minus 2 pi here, 3 half pi around here, so happening around here. Okay, now you make with a straight line, and after that minus half pi, minus half pi around here. So it will be like this. After that, half pi around here. Okay. And 3 half pi. Okay. Don't forget to using millimeter block to create your graph, because through millimeter block you can sketch the precise graph. Okay, that's number 6. Now we are going to move to number 7. Right. Solve exactly for 0 for x interval 0 to x. All right. Second x equals 2. If second x equals 2, it means 1 over cosine x. Yeah, 1 over a 1 over cosine x equals 2. Okay, so it means cosecant x equals half, opposite of this number. This 2 actually is 2 over 1. So cosine x equals half. And it's happening on x equals pi third. Okay, because the interval x to pi in quadrant, it's happening as long as the first quadrant, the quadrant 1 and quadrant 2. Yeah, so cosine x equals half, and then cosine, and then x equals 2 pi, it means from 0 to here. So it's happening on here and here. Yeah, quadrant 1 and 4. So it means x third, pi over third, and then 2 pi minus pi third. So it becomes 6 minus 1, 5 third pi. Now B. Cosecant x equals negative root 2. Cosecant, it means 1 over sine x. It means sine x equals 1 over minus root 2. Okay. Or it is minus half root 2, like that. Okay. Or minus root 2 over 2. Okay. Now, so it's happening on quadrant with, of course, a sign negative, okay, happening on this quadrant and this quadrant, okay. Quadrant 3, quadrant 2, sorry, 2 and 3, okay. So x equals 5, 4 pi, okay, and then x equals 5 4 pi plus pi half equals 7. Wait, this is 2 4. Okay, 7 4 pi. Okay, wow. C. Okay, root 3 should moving to right side. So it's gonna be secant to x equals minus 2 over root 3. Okay, right. So it will be second cos. Yeah, cosine. Cosine to x equals minus root 3 half. Okay. So it's happening cosine positive happening on this quadrant, cosine positive here, okay, and here, 1 and 4. So it's happening, it's cosine to x equals 5 pi over 6. So it means x equals 5 pi over 12. Okay, this is the first x. And the next is x equals 5 pi over 12. Okay. Because of uh, yeah, minus, yeah, minus, wait, oh, cosine x is minus, it means not here, minus root, minus at here, cosine minus here, 2 and 3. So it means cosine, it means x equals 5 pi over 12 plus pi over 6. It's going to be 7 pi over 12 because this is 2, 12. And after that, the next x, okay, 5 pi over 12 plus pi, 12 over 12, 17. And x equals, wait, going to scroll down, right? 5 pi over 12 plus 7 over 6 pi. Okay. Equals 19. 19 over 12. Yeah. Yeah. Pi. Okay. D cosecant x plus pi over 6 equals minus, yeah, minus root 2. So it means sine x plus pi over 6 equals minus 1 over, sorry, 1 over 1 over root 2 or minus yeah, root 2 over 2. If you multiply by root 2 over root 2. All right. Now we are going to determine x. This is sine. We have to find sine. Yeah, 5 pi 4. Okay. Then x plus pi 6 equals pi 4 pi. So x equals 5 4 pi minus pi 6 equals denominator being 12. Okay, 12. So 12, 3 times 5, 15. And 2 times pi, 2 pi. I'm going to scroll down. Okay. So x equals 13 over 12. 13 over 12 pi. Then after that, this is the first one. Sine x plus pi over 6 as well equals sine 7 4 pi. I have to move around here. Okay. So I will clean this area. Okay. If sine positive happening on quadrant 1 and quadrant 2. Yeah, sign positive happening on quadrant 1 and quadrant 2. So I'm going to move here. So it means, yeah, this. Okay. The pointers are to here. So x plus pi 6 equals 7 4 pi. So x was 7 4 pi minus pi 6. Or as well, denominator as well. 3 times 7, 21 pi. 2 times 1, 2 pi. Okay. So if calculate this becomes 19 over 12 pi. Next, E and F. Cotangent x equals -1. This cotangent is inverse of tangent, so it means tangent x equals 1 over -1. It means still -1. So tangent x equals tangent 3/4. So it means x equals 3/4 pi. Tangent positive, tangent has, yeah, tangent has negative, okay, on this quadrant, okay, and this quadrant means x 3/4 pi plus pi. 4 plus 3, 7 pi over 4. And next f. Cotangent, yeah, cotangent to x minus pi 4 equals positive √3. Tangent is inverse of tangent, so it means tangent 2x minus pi 4 equals 1 over √3. So it means tangent x minus 1/4. Okay, I will calculate first with calculator. Right. One over √3. Wait, it becomes okay 30. So it is 30. Okay. Pi over 6. So it means 2x equals pi over 6 minus, plus pi over 4. It is 12 as well. The denominator 2 pi, 3 pi. So this is 5 pi. So x equals 5 over 24 pi. Tangent positive happening on this this quadrant and this quadrant as well. So it means the next x is x equals 5 for pi plus pi. 9, 24 pi. Move to number 8. Wow. Number 8, solve exactly for interval 0 to 2 pi. A 2 sine x plus cosecant x equals 3. Okay. Cosecant x, I'm going to change being 1 over sine x. Okay. 2 sine x plus 1 over sine x equals 3. And after that, I will multiply by sine x. So this equation will be 2 sine squared x plus 1 minus 3 sine x equals 0, or 2 sine squared x minus 3 sine x minus, plus 1 equals 0. Let x equals sine x. If x equals sine x, it means this equation becomes 2x squared minus 3x plus 1 equals 0. Through factorization, I'm going to scroll down first. To the factorization, that it will be 2x times x plus 0, 2x minus 1, and x minus 1 as well, right? And it is 2x equals 1. Okay, it means 2 sine x equals 1, or sine x equals 1. If sine x equals 1, the solutions x equals pi half. So how about this? It means sine x equals 1 half. If sine x equals 1 half, so x equals pi over 6, and x equals x equals pi over 6 plus pi. No, I mean pi minus, because sign positive happening on this quadrant and then this quadrant. So it means 180 minus 1 equals 5 pi over 6. So the solution, x equals pi over 6, pi half, and 5 pi over 6. Okay. Last one. 2 cosine x equals secant x. B. I'm gonna change this secant x becomes cosecant x. So this equation becomes 2 cosecant x 1 over cosecant x multiplied by cosecant x. So this equation being 2 cosecant squared x equals 1. So cosecant squared x, I'm gonna scroll down. Cosecant squared x equals half. So cosecant x equals square root half or 1 over root 2. Yeah. 1 over 2, but plus and minus. So there are two values of x, plus 1 over root 2 and minus 1 over root 2. Now we are going to determine x. So x equals, this is happening on if cosine positive, happening on all quadrants, 1, 2, 3, 4. So it happening on x equals pi over 4. Okay. And then pi over 4 plus pi half equals, this is, wait, pi 5 or pi over 4, yeah, 5, 4, 4, yeah. Then after that, oh, sorry, not 5 or 4, because here first on the second, okay, on quadrant 2. On quadrant 2, it means, wait, minus, yeah, 4, this is, oh, plus, please, it's still plus, so it will be 3, 4, not 5, sorry. The next x, on quadrant 3, 2, 2 or 5. And quadrant 4, plus, it will be, this is 2, 7. I'm going to scroll down first. Oh, see? Okay. I'm going to clean first this area. Okay. I forgot to clean first this one before convert to PDF. Right. Now, this tangent squared x minus 2 minus 3 cotangent squared x equals 0. So it will be, I'm going to change this cotangent becomes tangent. So tangent squared x minus 2. 2 I will move here. Okay. Oh, it's okay. Sorry, I have to clean first. Will make us confused later if still have this. Okay, this one. Okay, right. So this equation will be tangent squared x minus 3 times 1 over tangent squared x equals 2. If multiplied by tangent squared x, it will be tangent power 4x minus 3 equals 2 tangent squared x, or this equation being tangent power 4x minus 2 tangent squared x minus 3 equals 0. Let x equals tangent squared x, meaning this equation becomes x squared minus 2x minus 3 equals 0. So we can factorize comes x and x as well, minus 3 and plus 1. Okay. So this is x equals 3, or tangent squared x equals 3, or tangent squared x equals negative 1. This is tangent x plus minus root 3. Okay. This is tangent x root minus 1. So there is no solution because this is square, it is root negative 1. So we are going to focus on this tangent. Tangent x equals positive negative root 3. So x equals pi third. Then x equals pi minus pi third to pi third. After that, x equals 2 pi third plus pi equals pi, I mean pi third, this one. Yeah, not 2 pi, pi third equals plus pi equals 4. 4 third pi, and then x equals 2 pi minus pi third 6 minus 1, 5. Okay. Now D, it is C. I will convert this. Becomes 1 over sine. Okay. If convert into 1 over sine, this equation becomes 4 sine x root 3 over sine x plus 2 minus 2 root 3. After that, multiply by sine x, and it's going to be 4 sine squared x equals root 3 plus 2 sine x minus 2 root 3 sine x. Next, 4 sine squared x minus 2 sine x equals root 3 minus 2 root 3 sine x. So it's going to be 2 sine x times 2 sine x as well, minus 1 equals root 3, 1 minus 2 sine x. Or I'm gonna change this one, this expression, 2 sine x times 2 minus 2 sine x minus 1 equals minus root 3 times 2 sine x minus 1. And they have same expression. So divide by 2 sine x minus 1. Okay, divide. It's going to be 2 sine x equals minus root 3. Minus root 3, and it will be, it means positive and negative as well, because root 3. So sine x would be minus root 3 over 2. Okay. So x pi over 6. Then x equals pi minus pi over 6 on quadrant 2. After that, x equals pi over 6, 5 over 6 pi plus half pi. 3 8 over 6. 8 over 6, 4 third. And then 4 third plus 1 quadrant 4, it means pi third. 5 third pi. Or 2 pi minus 2 pi minus 4 over 6, 4 over 3. This is 2 pi minus, because on quadrant 4. 2 pi minus 4 third pi. So it's gonna be 6. No, I mean it must be 5 over 6 minus 4. It's gonna be 2. Oh, I think just now. But it's just now plus plus. Yeah. Number 9. Consider the diagram alongside. Okay. A. Cosine theta. Cosine theta, this theta, cosine is, this is 1. Okay. Oh yeah, AD. Okay. Cosine AD over cosine theta is, yeah, this is 1. This is 1. Okay. Yeah, this one, it means if cosine OD, yeah, okay, OD over OD over 1. Okay, equals OD. If sine is AD over 1. Sine theta. Sine theta is AD. Yeah, sine theta AD over 1 equals AD. See? Tangent theta. Tangent theta BE over OE equals BE. OE equals 1, so it is BE. D secant theta. Secant theta is cosine 1 over cosine theta. So it means cosine theta, yeah, OE over OP, because cosine theta is cosine theta is OE over OB. Yeah, 1 over cosine theta, 1 over cosine theta, OE over OB. So it means this is OB over OE. because OE equals 1. We're going to scroll down first. Cosecant theta 1 over sine theta. Sine 1 over sine theta. Sine theta is sine theta CF over O OC. OC is, yeah, this CE is CF is 1. Okay, so 1 over CF over OC. OC over CF. CF equals 1. It means this is OC. Cotangent theta. Cotangent theta equals 1 over tangent theta. 1 over, let me look, tangent theta. Tangent theta OF, sorry, CF over OF. Okay. CF over OF or OF over CF. CF equals 1, it means this is OF.